Hello viewers, I welcome you all in this today's very important discussion. And today we are going to start free videos, free session for you on physical geography. This physical geography would be talking about all the physical aspects of geography. This is a series of lectures which you'll get on YouTube channel of N by IAS. So today's lecture, we are going to talk about the latitudes and longitudes, and we will see that why these latitudes and longitudes are important, what was the need of having latitudes and longitudes, and after we learn about what are latitudes and longitudes and what are the uses of them, why is it important for us. After that, we will be looking up some aspects of rotation of Earth, how the date, time, all these things are decided, and we will be proceeding about the rotation of Earth. So it will also cover some part which will explain you that why certain regions are formed, what are the important latitudes, what are the important longitudes, how they are decided, and all these things. So very first, it is important to understand that why was need of latitudes and longitudes was felt. In a very brief, I will be explaining you this. After that, we will be going on to latitudes and longitudes separately, which will cover your factual things. But first of all, you need to understand the importance of latitudes and longitudes. Now just think of a situation. For example, if this is your Earth, okay, and we have Africa over here, and then we have India over here, and then there is China, there is Russia, all these states are there. Then there is European countries, all such places you can see on Earth. Now if I try to ask you that you tell me where is India, you can very well tell, so that this is the part where India is located. Now let's zoom into it. Now this is what your India is. This is the southern part. Here are the Himalayas. Now if I ask you that tell me where is Delhi, you may say, sir, it is somewhat bit in here. Okay. Now let's zoom Delhi also. Now if I tell you in Delhi, if suppose this is the map of Delhi and I ask you where is Karol Bagh, that becomes a bit difficult situation for you. If I ask you in Karol Bagh, where is N BY IAS Institute? So then it becomes more difficult because in Karol Bagh there are several locations. So now, as we have understood that location finding is very important aspect. Today the missiles are guided with the help of coordinates, with the locations. The air flights, the plane, they travel with the help of locations. Air travel, when travel by air, we come to know that we are going to Calcutta from Delhi or Delhi from Calcutta. But how the pilot knows the route, how the pilot knows where the airport is and where we have to land. It's not that easy as you go by your vehicle by road. That is not the case because it's all open. So in that case, 3D maps or 3D axes are important, where latitudes, longitudes, as well as the height is also important. Because when we travel in space, then 3D, x-axis is important, your y-axis is important, and your z-axis also is important, which is coming out, which is the 3D space. Now, after you get about all these, now just try to understand that if you come to know that which is the part on our Earth, if you want to locate it. So this is, if your Earth, okay, and you want to locate some part on Earth, then how will you locate it? That is the real need of latitudes and longitudes all about. So what are latitudes? Latitude, in a very simple language, if I tell you, you know that 0 degree exists. You know that 23 degree and half, your Tropic of Cancer. 23 and half degrees, this is north, this is south, this is Tropic of Capricorn. And then your Arctic and Antarctic circle is also there. Now the 0 degree is an imaginary line. This is a latitude. How they are formed? Why is it 0 degree? Why is it 23 and a half degree? Why is it, at the poles we call it 90 degree? Why is it 90 degree at poles? Those things I'll explain you just after this. But you understand, now this is 0 degree, and somewhat here our India is there. Somewhat here Africa is there. Okay. So now why is it important to understand a 0 degree or 23 degree and all? Because when I ask you in a simple manner that India, it lies in which of the hemispheres? So this hemisphere is divided by the 0 degree equator. This is your northern hemisphere and this is your southern hemisphere. So first very important thing about the latitudes is that 0 degree is the biggest latitude, the largest latitude. That's equator. And with the reference of equator, we can find out which is the northern hemisphere and which is the southern hemisphere. This is one aspect. Now, if I tell you there can be, these all are imaginary lines. So this 0 degree and 23 degree we have marked, but before that also, there are several other degrees in between as well. You know, there are several other degrees. Now, all the degrees or all the latitudes above the 0 degree in the upper side, those will be in the northern hemisphere. That is why this is called as 23.5 degree north. Maybe this is 5 degrees north. We won't call it 5 degrees south. Why? Because it is in the northern hemisphere. When we come to the southern hemisphere, this is 0 degree. Maybe this is your 5 degrees south. This is your 10 degrees south. This is your 20 degrees south, and then so on. Now, why is it only Tropic of Cancer and Capricorn? We know that has an impact of sunlight falling on it and the tilt of axis. I'll explain you all these things. So I hope that you have got all the important aspect of what the latitudes are. Now, when we come to longitudes, why are longitudes important? Now, if I tell you to mark me that where is India, where is a place in India, you can say itself that it passes through some degrees, which is this degree. But you can also see that, for example, if this is India, or if this is, for example, any place in India, so the same degree is also passed by other countries also. Now you can find the place, this 23 degrees and half, this is the total 23 degree half in whole of the earth. So all the countries which are lying on this line would be lying on 23 degree and half to the north, and all the continents, Australia and countries which are lying to the south, they would be of some latitude towards the south. But now how to locate the place? Because you have got the x-axis only. This is your x-axis. Latitudes, they give you information about the x-axis only. But if you want to point some some place or some coordinates in this region, or this, if you want to know the value of this coordinate, or this one or this one, so location, if you have to find it on a 2D space, so that is your land. So how to do that? You also need, for that, it's not only that latitudes are sufficient. What you need for that, you need the longitudes as well. So these are your longitudes. These would be the longitudes. And longitudes, they are the imaginary line again, which joins northern pole to the southern pole. Okay, these latitudes, they are the concentric circle. Try to imagine these latitudes, they would be covering, if this is your earth, they would be covering it whole. Okay, longitudes, they will be covering from north to south, imaginary lines. Same in the backside, which you cannot see in the board. Okay, so these are the concentric circles, and these are the semicircles. These are the lines which join one half of the northern to southern. I'll tell you all these things in detail. Now just focus on this, that these are the longitudes. Just remember, longitudes, long, so they are connecting from northern to southern hemisphere, southern pole rather, and latitudes, they are connecting, they are the concentric circles. Okay. now it is important for you, I think, to understand that how longitudes are also important. Now longitudes, you can assume them as your y-axis. So now you have the x-axis. This is your x-axis, and if you want to know the location of this part, so you have to know the y-axis as well. Okay, so this is where your y-axis comes into existence. This is, for example, let's take, this is 0, this is x-axis, this is your y-axis. Now if you want to locate this place, this is how you do. In general mathematics, you might have studied also, this is how you do, and you get the coordinates of this place. The same way it is done in the case of locating any place on earth as well. So this is why we need latitude and longitude. I hope this is very clear. Now what are latitudes? Now comes the part where I am going to explain you that how we decide the degrees of latitudes. I have just told you this is 0 degree, this is your 23 and a half, this is 23 and a half, this is 5 degrees, 10 degrees. But how these degrees are decided? Say for example, if you cut your earth, which is not a perfect sphere, but we still assume that it's like a sphere. It's like a shape of egg, but we assume that it's like a sphere. And now this sphere, if you cut it from between, you can see that this type of, this is the, if you cut the sphere like this, so this is what you get in the front view. Okay, so this is what we have. This is what we have. This, just try to imagine this figure. We have cut it from between, and this is what we have. Okay, now this is, after getting this, we took an imaginary line, which is the longest latitude. As I've told you, what is this? This is the 0 degree. Same way, x-axis. Just forget about everything. Just follow it like this is an x-axis. Okay, now I tell you, draw 10 degrees to in the reference to this x-axis. So what will you do? You will put your protector. Okay, you will mark 10 degrees. You will mark the line in your protector. You will mark the line, and you will say that this is somewhere where 10 degrees is coming, right? And you will join this 10 degrees like this. I say 20 degree, angle will increase. This is some, just for reference case, just understand, not to scale as such. And when I call you, draw 45 degrees, this will be your 45 degrees, this will be your 60 degree, this will be your 80 degree or 75 degree, and this will be your 90 degree. Very clear? General mathematics, you all might have studied in class 10. So this is your 90 degree. So that is why we say it, that the latitude at pole, this is 90 degree. Okay. Now, just forget this part. I'll just explain you. I'll rub the things and you will get it understood. Now, I have rubbed all these things. Okay. This is also gone. Now, this is the part of Earth which we can see on the above the surface, this part. Okay. Now, this is your 10 degree. Now, what we have done, this 10 degree would be the same in reference with 0, in reference with your equator. So, this is your 10 degree. So, this is the line. This is the total line we drew of 10 degrees. This is the line we drew for 20. This is the line we drew for 45. This is the line for 60. This is 80. And here is 90. So this is what you can see, the part of Earth. And this is how we decide this is 0 degree, this is 10 degree, 20 degree, 45 degree, 60 degree, and so on. Same goes, this is your northern hemisphere. And same goes for southern hemisphere as well. Same way, you keep a protector over here, you draw 10 degrees, you draw 20 degrees, 45 degrees, 80 degree, and your 90 degree. Same way, there is no difference. So this is how we decide what is the angular, which latitudes we are talking about. So this is how it comes to degrees. Because when you see on the sphere, you must find it difficult that if this is 0 degree, how we decided this as 20 or 25 or something like that. So this is how it is decided. Now latitudes. What are latitudes? Some important facts, very quick revision. Latitudes, they are parallel. The distance between two latitudes, they will always be equal. Distance between two latitudes means 10 degrees to the north and 10 degrees to the south, they will be always equal. 20 degrees to the north and 20 degrees south to be always equal. Okay, 30 degree and 30 degree north south, they will always be equal. You can see that they are running parallel. Okay, parallel because 2 degrees lines are drawn, and lines, when they are in a single toward a single point, they are moving only in one direction, then they will never meet. They are parallels. Okay, so these latitudes, they are also known as parallels. They run in east-west direction. Okay, this is your, for example, this is your east, this is your west. So they run in east-west direction, and they never run in north-south. North-south mein latitudes nahi hota hai, it's longitude. Okay, right. So they run in east and west direction. Measure distance north or south from equator. Okay, how they measure distance north to south of equator? This is your north, this is your south, right? We are measuring the distance also here. This distance is in degree definitely. So 10 degrees north, 22.5 degrees north, 35 degrees north. So this is how we calculate the distance. And as I've told, they are always parallel and they never meet. So that is why the places they are on 10 degrees, they will always be in 10 degrees only. Cross the prime meridian right triangles. Now what is prime meridian? These are the prime meridians. 0 degree is basically the prime meridian. Okay, 0 degree is called these are the meridians, and 0 degree is called the prime meridian. Say for example, this is your 0 degree, it passes through Greenwich in London. So this is your 0 degree. Okay, this is your 0 degree. 0 degree and all these, this is just a reference. There is no such, there is no such rule that 0 degree has to be, for passing from London, unless and until it was decided so, because a reference point has to be taken, and it is passing through Greenwich in London because at that time, in 1884 or 5, when it was decided that 0 degree would be the reference point for taking all the longitudes, then it was decided because first of all the there was an observatory in Greenwich where all the scientists and all, they were working on this latitude and longitude, and they took it as a reference point. And obviously Britain was ruling throughout the world, so they were technically and they were mathematically very sound, and they were doing all this research. So obviously they gave the 0 degree passing from their country. Now say for example, if the 0 degree wouldn't be passing from London, if it would have been passing from India, the whole time system of the world would have been different. Sun would have taken, sun would have risen from at the same time and everything, but this latitudes, the degrees, the longitudes, all these would have changed. Latitudes would have remained the same because of the equator, and longitudes would have changed because the degrees of the longitudes would have been different. So प्लेसेस में फर्क कहाँ आता, अगर 0 डिग्री ग्रीनविच से पास नहीं करता, किसी और कंट्री से पास करता, तो आपके ईस्ट और वेस्ट कोऑर्डिनेट्स में देयर आर ऑलवेज नॉट 45 degrees north, 23 degrees east, like this. It won't be 45 degrees north, 25 degrees south. It won't be like that. ठीक है, तो या तो इस हेमिस्फेयर में होगा और 0 डिग्री मेरिडियन के इस साइड होगी प्लेस, या तो उस साइड होगी. तो फॉर रेफरेंस इट हैज बीन टेकन लाइक दिस. लाई इन प्लेन्स दैट क्रॉस द अर्थ एक्सिस एट राइट एंगल्स. ठीक है, अर्थ की एक्सिस, ये अर्थ की एक्सिस हम लेते हैं, ये है पास हो रहा है 90 डिग्री 90 डिग्री, ये पास हो रहा है, ये पास हो रहा है, ये पास हो रहा है, ये पास हो रहा है. सो ऑल दीज आर 90 डिग्री. ठीक है, गेट शॉर्टर टुवर्ड्स द पोल्स विथ ओनली इक्वेटर द लॉन्गेस्ट अ ग्रेट सर्कल. That's what I have explained you earlier also, that since equator is the longest circle, so we have taken this as a 0 degree as a reference point, and they get shorter. You can see that 0 degree is the longest, then 10 degree is a bit shorter than 0 degree, 20 degree is more shorter means the total length. because ये क्यों है, simple mathematics है. simple mathematics क्या है कि sphere है, it's not a plane, sphere है, sphere में we are moving towards the pole, so distance, it's a curvature, so distance keep on decreasing. Distance between, that is why 0 is the longest and polar it's the shortest. ठीक है, 90 degree is the shortest and 0 degree is the longest. So this is how it goes. Now zones on earth. Now zones on earth are also dependent on latitudes. How so? Zones on earth are decided on the way that which part of the earth is receiving how much amount of sunlight. Now this is a connected aspect with latitudes. These are the zones. Okay, frigid zone, temperate zone, torrid zone, and again this is your 0 degree, this is your 23.5 degree, this is your 66.5 degree, and this is your 90 degree towards the north. Same goes with south, 0 degree, 23.5 degree south, then your 60 and 66.5 degree south, then your 90 degrees south. This is your southern pole and this is your northern pole. Now just remember, as I've told you, that this 23.5 degree and 23.5 degree, this is a torrid zone. Torrid zone is a zone, I'll explain you how these zones are created as well, but for now just understand that this torrid zone, this receives the maximum amount of sunlight throughout the year. कैसे होता है, I'll explain you. How is it done, that I'll explain you, but maximum amount of sunlight is received by this torrid zone. So एक zone को decide किया गया कि this 23.5 और north और south के बीच में जो zone होगा, that we will be calling as torrid zone. अब torrid zone के बाद the next zone which is there is temperate zone. Now this temperate zone, it receives a bit less amount of sunlight. ठीक है, this receives a less amount of sunlight. Why? वो भी मैं बताऊंगा, बिकॉज सन इज फॉलिंग स्ट्रेट ऑन टॉरिड जोन एरिया, ठीक है। मूवमेंट ऑफ सन जो होता है अपरेंट मूवमेंट विच इज कॉल्ड, वो 23.5 to 23.5 होता है। वो भी क्यों होता है, आई विल एक्सप्लेन यू, बिकॉज द टिल्ट ऑफ द एक्सिस। एंड देन दिस टेम्परेट इज बिटवीन 23 and 66 degree half, ठीक है। दिस इज द टेम्परेट जोन जहां आपके ऑल दीज कंट्रीज, यूरोप एंड स्कैंडिनेवियन कंट्रीज, दे लाई इन दिस टेम्परेट जोन, दैट्स व्हाई दीज आर ऑलवेज कवर्ड बाय स्नो, ठीक है। दिस मैक्सिमम बिग snowy hills and mountains are in this temperate zone only. Then after temperate it is frigid. Now this frigid zone, this receives very less amount of sunlight. और एक टाइम तो ऐसा भी आता है कि for 6 months this north zone don't receive any sunlight, and this 6 months in the southern pole they also don't receive the sunlight. This also comes, that I'll explain you कब होता है, कैसे होता है, what is the requirement for that, वो कब होता है, that all things I explain you. बस अभी के लिए आप ये चीज देख लीजिए कि these are the zone of earth. Moving ahead, now this zone of earth, now let me explain you how these zones are formed. This is your earth, ठीक है। अभी ये अर्थ को हम मानते हैं कि ये इसका एक्सिस है। We take this as an axis of earth. Now what is an axis of earth? Axis of earth है जिसमें अर्थ रोटेट करता है, रोटेशन एंड रिवोल्यूशन, वो भी हम बात करेंगे अभी। Now this is the axis of earth. It is not tilted, it is directly at your 90 degrees only, ठीक है। और ये एक्सिस ऑफ अर्थ है, इस एक्सिस को हम रेफरेंस पॉइंट 0 डिग्री ले लेते हैं। अब अगर मान लीजिए आप कि इस एक्सिस ऑफ अर्थ पे दिस इज योर सन, ओके, नाउ दिस इज योर सन, ठीक है। And this is the area where sunlight is continuously falling. You can see this is a straight, sunlight is continuously falling. Now this sunlight is continuously falling in this area, and this is your 0 degree reference. ये होता है आपका 5 to 10 degrees north, और ये होता है 5 to 10 degrees south. Okay. Now this, अगर अर्थ की, if earth axis won't have been tilted, so this would have been the torrid zone. यहाँ पे torrid zone क्या था, ट्रॉपिक ऑफ कैंसर से लेके ट्रॉपिक ऑफ कैप्रिकॉर्न तक, मैक्सिमम अमाउंट ऑफ सनलाइट। इफ दिस इज बिकॉज ऑफ द टिल्ट ऑफ द एक्सिस, 23.5 डिग्रीज टिल्ट, तो 23.5 डिग्रीज यहाँ पे उसका इफेक्ट। नाउ अगर वो टिल्ट नहीं होता तो दिस वुड हैव बीन दी टॉरिड जोन। यहाँ पे जो सनलाइट है ये हमेशा इक्वल होती, और यहाँ पे जो सनलाइट है ये भी हमेशा इक्वल होती, अगर एक्सिस नहीं होता तो, टिल्ट ऑफ एक्सिस नहीं होता तो। नाउ लेट्स सी, बिकॉज ऑफ टिल्ट ऑफ एक्सिस व्हाट इज हैपनिंग। दिस इज अगेन, यहां पे आपका सन है, ठीक है, और आपका अर्थ है, ये आपका अर्थ है, ये आपका रेफरेंस था जो हमने बात की थी, और आपका टिल्ट ये हो गया। अब टिल्ट अगर ये हो गया तो नॉर्दर्न एंड सदर्न पोल तो वही रहेगा, यहां पे दिस इज योर नॉर्दर्न पोल, नॉट दिस वन, दिस इज योर नॉर्दर्न पोल, दिस इज योर सदर्न पोल। अब क्या हुआ, आप देखिए कि ये टिल्ट जो है, दिस टिल्ट इज 23.5 डिग्रीज। अब ये टिल्ट 23.5 डिग्रीज हो गया, तो जब ये टिल्ट ऐसा है तो 23.5 डिग्रीज के जो सनलाइट पड़ रहा है आपका, ठीक है, दिस इज द एरिया वेयर सनलाइट इज फॉलिंग द मैक्सिमम, दिस एरिया, ये एरिया। नाउ दिस इज द एरिया वेयर सनलाइट इज फॉलिंग मैक्सिमम व्हेन द टिल्ट इज लाइक दिस। सो दिस इज योर 23.5 डिग्रीज नॉर्थ, ठीक है। लेकिन यहां पे 23.5 डिग्रीज पे नहीं पड़ रहा है सन, बिकॉज इसका जो टिल्ट है वो नॉर्दर्न हेमिस्फीयर की तरफ अभी आपको दिख रहा है, और सदर्न हेमिस्फीयर थोड़ा ऊपर आ गया है, तो मैक्सिमम अमाउंट ऑफ सनलाइट इज फॉलिंग ऑन नॉर्दर्न हेमिस्फीयर, एंड दिस इज द टाइम व्हेन वी कॉल इट समर सॉल्स्टिस, ठीक है। अब इस लोकेशन को, इस सिचुएशन को आप उल्टा करके समझिए कि इफ द सेम सिचुएशन गोज ऑन लाइक दिस, नाउ इफ दिस इज योर अर्थ एंड दिस इज द कंडीशन, ठीक है, एंड दिस इज योर नॉर्थ पोल, दिस इज योर साउथ पोल, यहीं पे आपका सन है, तो अब क्या हो रहा है, मैक्सिमम ऑफ सनलाइट, ओके। सो दिस इज योर 0 डिग्री। अब यहां पे 23.5 डिग्रीज पे मैक्सिमम सनलाइट पड़ रही है। तो ये आप देखो कि दो सिचुएशन में दो सिचुएशन कैसे आती हैं वो मैं बताता हूँ. वो in those two situations you can see that the sunlight is being distributed maximum towards 23.5 degrees of north, जो ये आपका है Tropic of Cancer, and 23.5 degrees south because of the tilt. ठीक है, तो this is how it goes. So ये जो एवरेज हम निकालेंगे अगर, तो ये 23.5 से 23.5 का होता है. That is why that is torrid zone. After torrid there is temperate, against less amount of sunlight, and then very minimal sunlight which falls on poles, that is 90 degrees. And this is the reason why the polar region are always covered with snow and ice, because sunlight cannot reach there, and that is why there is very cold temperature of minus 80, minus 100 degrees Celsius, and that is the reason why the colder regions are towards the pole. Another aspect why the colder regions are toward the pole is also because of the curvature of the earth. Now how curvature of the earth is responsible for that? Curvature of the earth आप देखो अगर, तो curvature of the earth is not straight line, it is circular line. अब अगर if you see that sunlight, ठीक है, it is falling here directly, it is falling इस area में, तो जो sunlight है that is concentrated in a very small area. When the sunlight is falling in this area, same sunlight, यही sunlight जब fall करिए, तो आप देखो कि the area which is covered that is increasing. When we take this area, so ये और increase हो जा रहा है, ठीक है, तो you can see that on equator the area is less, and when we move towards the pole the area keeps on increasing. Now when the sunlight is focusing on less area, the same amount of sunlight is focusing on a smaller area, concentrated area, so the heat would be very high in this area. जैसे ही रे slant होने लगी, तो the heat would reduce a bit, थोड़ा सा कम हो जाएगा, और इस एरिया में बहुत ज़्यादा slanting rays पड़ेंगी, तो the heat is reduced to a great level, and that is why heat बहुत high होती है, snowy areas होते हैं, and because of which the snow cannot melt, and that is why northern and southern pole they always remain covered with snow. This is what I explained you. Same diagram is given over here. You can see heat zones of earth. As I have told you, I have explained you this. See this area is less, this area is a bit more, and then this area is again more. So this is how it is decided. The moment of the rotation and the revolution basically of earth, the tilt of axis, it keeps the maximum intensity of sunlight from summer solstice to winter solstice. ये क्या होता है, I'll explain you. And it is maximum with Tropic of Cancer to Tropic of Capricorn, this area, and that is why you can see that these areas are falling in tropical regions. ठीक है, above it is temperate regions, Scandinavian countries very cold, Russia too cold, Canada again very cold, India not so cold. Now what is the reason? This is the only reason, because यहाँ पे sunlight हमेशा होती है. इक्वेटर के ऊपर आप जैसे ही जाओगे और हीट होगा, तो all these things are the reason, and this is how the zones are created: 0 degree, 23 degree, 66 degree and half, and then this is 90 degree, all northern hemisphere, and this is all in the southern hemisphere. So this is how we decide the heat zones of earth. This is how it is done. It is very basic and you all must be understanding it. Now rotation and revolution of earth आता है. Rotation and revolution मैंने आपको थोड़ा बहुत I have explained you, but still rotation of earth causes day and night. How it causes day and night, that we'll see. Earth rotates from west to east. The sun rises from east to west, but the earth rotates from west to east. If you go to the northern pole, if you go to space and you watch the earth from the northern hemisphere, then you can see that the earth is rotating in anti-clockwise direction. And if you go to the southern hemisphere, you can see that the earth is rotating in clockwise direction. So anti-clockwise direction is from west to east, this way. This is your west, this is your east. So it rotates in such way from west to east, that is from your anti-clockwise direction. The northern hemisphere, this is your northern hemisphere, and this is your southern hemisphere. So this is how it is moving. Okay, now you can see here that it is moving in this way. Now, why is it moving in this way? That has a different Big Bang theory है उसमें, कि when all the when there was a bombardment of of a great star, so all the planets they emerged, और वो emerge की एक force के साथ, and that force was in this direction, and that is why all the maximum number of planets they are moving in west to east direction, that is anti-clockwise direction. Now this you can see, if you can see that this is the part from where your sun is falling on. If you see this part, this is the part from where your sunlights are coming. Okay? And sunlight is falling on this part. Now you see this area, this is under the sunlight. तो यहाँ पे क्या होगा? It would be day. This area is not having any sunlight. So यहाँ पे क्या होगा? It would be night. Now this earth is continuously rotating, sun is static, sun is not moving, this earth is rotating, and due to the rotation of earth, the day and night phenomenon, it take place. This is the reason it happens because of the rotation of earth on its axis. This axis you can see it is tilted with 23.5 degrees. ठीक है. अब ये जो डायग्राम दिख रहा है आपको, यहाँ पे नॉर्दर्न पोल में it is maximum sunlight is falling on the northern pole. So this is your summer solstice. Okay, and you can see that the southern hemisphere is not very near to sun, it is very far. So in this case, northern hemisphere receives sunlight for maximum amount of time. For 6 months rather, there is no there is no night in northern hemisphere when there is a summer solstice in the month of June. So at that time it's always covered with sunlight. In the northern pole you can see daylight every time, and southern hemisphere is at that time total under darkness. Same occurs when the reverse happens. So this is your rotation. Now this comes your revolution. Okay, revolution, one revolution around the sun. This is the orbit of the earth. Earth orbit is not circular, it is elliptical. You can see this earth ki orbit jo hai, that is elliptical. This is the sun in between, and this is your earth. Okay, ab this earth is moving around this elliptical orbit with some speed. Just focus it and try to see it. Since it is elliptical, you can see that this length between earth and sun is much more than this. So this is high, this is of greater length, and this is your north hemisphere. Okay, and when the earth you'll just see that when the earth it rotates, it does a revolution around its axis around the sun. How does it look like? So this is the way earth is moving. Okay, now earth is moving in this way. When the earth comes into this location, this is an equinox. Why equinox? Because the sunlight which is falling on northern and southern hemisphere will be the same. Okay, now when this earth it comes into this location, then also equinox occurs. Why again? Because the sunlight on the northern and southern hemisphere is again the same. So this would be the condition of equinox. And this condition, when the earth is at the farthest from the sun, this is the condition of solstice. Just remember like this is the condition of solstice, and this is the condition of equinox. Okay, so this is the rotation and revolution. Because of revolution also we get a lot of seasons, and winter and summer. This also is a major factor, not the only factor, because it has been studied that because of the revolution around its orbit, and because of this equinox and this solstice, there is only 6% of temperature change, heat budget change, not very much. There are other factors as well. So now we come to the topic which I was discussing about tilt of axis and the summer solstice and winter solstice. So now look at this diagram very carefully. This is just a representation of this diagram in a more holistic manner. This is your northern hemisphere, this is your southern hemisphere. Very quickly, just go through it. I have just told you. In the northern hemisphere, you can see that the sunlight is falling in the maximum area. This is your equator. This is your northern hemisphere. ये area बहुत ज़्यादा है. And when you compare that area with this area is very less. Okay, so in the month of June, summer solstice takes place, and this summer solstice takes place, and northern hemisphere is receiving more amount of sunlight, and southern hemisphere is receiving less amount of sunlight. Let's come to this area. This is in month of September. This is called as equinox. Okay, this is your autumn equinox. So in the month of September, again equal amount of sunlight in the northern and southern hemisphere. This happens only for a day. It does not happen for a long time. ये यहाँ आता है, it comes to this position that for one day it happens, and then again it moves towards the solstice. Now when it goes from this area to this area, now this is your northern hemisphere, this is your southern hemisphere. Tell me which hemisphere is receiving the maximum amount of sunlight. You can see that this is the equator. This is the area where maximum amount of sunlight is falling. Okay, this is your southern hemisphere. So in winter solstice that happens in month of December, it is the southern hemisphere which receives maximum amount of sunlight, and that is the reason why during Christmas Australia has summer days. this Christmas is coming, and we can see that if you see the temperature of Australia and the countries which are lying in the southern hemisphere, they are hotter, and India and other countries which are lying in the northern hemisphere, they are colder. So this is the sunlight which is received by southern hemisphere in December, that is winter solstice. This is having much larger amount of sunlight, and this area is very less. So in winter, December solstice, maximum amount of sunlight is received by southern hemisphere and least sunlight is with the northern hemisphere. Now you think of a situation when this is the situation. Before it comes to this situation, maximum amount of sunlight is received by southern hemisphere, and this southern hemisphere has 6 months, around 6 months of daylight. You cannot see darkness during winter solstice that occurs in December. In southern hemisphere, you cannot see darkness. It's for 6 months, it's all the light. In northern hemisphere, when we come to June solstice, same thing happens during June solstice in the month of June. In northern hemisphere, this Arctic region, this has 6 months of sunlight, and this southern hemisphere, this is the same 6 month of darkness. तो जब winter solstice है तो north pole में पूरा dark. When summer solstice is there, then south pole is total dark. And this two are equinox. This is during autumn, this is during spring. It happens in the month of March. This happens in the month of September. Just remember the month: March, June, September, and December, because एक बार UPSC have asked this type of question, that what occurs in which part of the year. So this is how the tilt of axis is making a difference. So revolution and tilt of axis, just sum up. On this plane, the earth axis is not at right angles, but inclined as angle of 23.5 degrees from the perpendicular. That we have seen कि ये tilt है जो, this tilt is 23, it's not 90 degrees. ठीक है? So this is not 90 degrees. This, because of this tilt, this 23.5 degrees आप deduct कर दो, 63.5 सब बचता है. So this is not 90. That is what is written. This circumstance is responsible for the annual changes in the height of the sun above the horizon. Obviously, the height of the sun is changing above the horizon. This is going towards the northern hemisphere in a much more manner during the tilt of axis and during the summer solstice. और यहाँ पे southern hemisphere में ज़्यादा आ रहा है. So that is why it's responsible for annual change in the height of sun also above the horizon, and definitely the slanting rays are also responsible for that. So northern and southern hemisphere में ना, you will be looking at the sun which is very near to horizon. मतलब आपको sunrise और sunset जैसा you can see in tropical countries that sun is above your head. It's not the same in northern and southern hemisphere, because the the slanting rays and the tilt of axis also responsible is for the change of the horizon. During the two equinox, the circle of the illumination cuts through North Pole and the South Pole. That I have explained you. North Pole and South Pole cut करता है. That is why they are equinox. They are called equinox. Same amount of sunlight is received by northern and southern pole as well. On the June solstice, the circle of illumination is tangent to the Arctic Circle, and the region above the latitude receives 24 hours of daylight. ठीक है, तो जून solstice जिस दिन होता है उस दिन 24 hours of daylight होता है. बाकी in the June solstice as a total, when we say 6 months is maximum daylight and 6 months in south, it is total darkness. So this is how it is done, and the same opposite is in the December solstice for Arctic Circle. Solstice I have explained you just now. So this is the sun. This is your June solstice. When in June solstice, northern pole will receive maximum sunlight. In December solstice, it would be the southern hemisphere receiving the maximum sunlight, and that is why in December solstice, it is the southern hemisphere receiving summer, and in the June solstice, it would be the northern hemisphere which is receiving maximum amount of summer. Just remember one, another is total opposite to it. So this is the tilt of axis, very mathematical things, not very important for UPSC students. So this is the tilt of axis. This is 23 degrees, this is 66.5 degrees, and this is how the changes are done in the degrees, and that is why there is a change in, there is a solstice which is occurring. So agar this type of question comes, the solstice is the result of tilt of axis of Earth. So that is a true statement. ठीक है? On June 21st or 22nd, this is the June 21st or 21st second, that is what I have told you. So is then there would be maximum amount of sunlight on the northern hemisphere also, and daylight hota hai. And during the June semester solstice, also called as summer solstice in the northern hemisphere, all location north to the equator have day lengths greater than 12 hours. Definitely, the rotation is of Earth is for 12 hours, 24 hours, and 12 hours का यहाँ पे 12 hours से ज़्यादा का दिन होगा because northern hemisphere is receiving maximum amount of sunlight. On equator, it will be exactly 12 hours. Equator पे it will be exactly 12 hours. और solstice के ऊपर depend करता है कि maximum greater than 12 hours कहाँ होगा. It's whether on the June or December solstice. So this is how it is explained. Day and night, that I've explained you in the rotation when we were looking in the animation of rotation of Earth, that the part which is having a maximum amount of sunlight, that would be receiving the daylight, that would be day, there would be day, and night would be on the other opposite side. And northern or southern में किसमें ज़्यादा होगा, किसमें कम होगा, that also we have seen. Okay, so this is your sunlight, this is your sun, this is the sunlight which is falling, and all the other things which I have explained you, that is the same for this. So now let's look about longitudes. We have just spoken about and we have just discussed a bit about longitude a few minutes back. Now we'll be focusing on longitude and we'll be trying to understand that what is the importance of longitude. As I have also told you, you might have remembered that I have just explained you that how a location on any place on Earth can be decided not only by latitude, but longitudes are also very important. So these are the longitudes which travel from North Pole to South Pole. Always remember, the longitudes, they would be traveling from North Pole to South Pole. That is, if this is your Earth, okay, and this is your North Pole, this is your South Pole. So the lines, imaginary lines which are joining your North and South Pole, these are the longitudes. So these are the longitudes, okay, and prime meridian is the longitude which is at 0 degrees, right? So longitudes, they start from prime meridian. Prime meridian is the reference point and it passes from through Greenwich in London, as we have already spoken earlier. So now this Greenwich, this 0 degree meridian, this is called the prime meridian, passes through Greenwich, and all the other meridians, they are joined from North to South Pole. If we start talking about the standard meridians, then the standard meridians, they are placed at after the difference of 15 degrees. With difference of every 15 degrees is what is standard meridian. So 0 degree, then 15 degree, 30 degree, then is your 45 degrees, and so on. So this is the standard meridian, and there are total 24 standard meridians. That is 360 divided by 15, so that is 24. So total standard meridians are 24. Okay, so this is what I've told you about prime meridian. These are the standard meridians, and North to South Pole is what is imaginary line is joined, and that is what is your longitudes. Now let us explain and let us see that how we decided this as 15 degree, this as 30 degree, this as 45 degree. How is this decided? How we take it like this? So that also has a mathematical reason for that, is such that this is you see the Earth from top sphere, okay? This is your Earth. Now, somewhat here, this is the 0 degree. You see, you imagine that this is how it is, okay? So this is somewhere where equator is passing, right? This is your point of reference, and from this point of reference, you keep your projector and you take 15 degrees. So it lies here. This is your 15 degrees. This must be your 30 degrees. And this is how it increases, okay? And this is how, when we complete a full circle, a full sphere, then the line which is passing from this 15 degree would be the 15 degree longitude. The imaginary line passing through this 30 degree would be the 30 degree longitude, and so on. So this is how this longitude is decided, and the degrees are kept. Now, when I talk about that this is the Earth, okay, and this is your prime meridian, and these are the longitudes, right? Obviously, this is the prime meridian passing through Greenwich. This is 0 degree, and equal opposite side to the 0 degree would be 180 degree at the back side. because this is 0 degree, then 15, 30, 45, and then it will go on 60, and so exactly back it would be 180 degree. Mathematical again, full turn 360 degree. So this is how half from here to there, it is 180 degree. Now, one very important aspect of this prime meridian is also, or rather the longitude is also, that these longitudes, they help us in deciding the time on a particular place. That what would be the time on a particular place on this longitudes. Obviously, as we have seen that equator, it divides Earth into equal halves, that is northern and southern hemisphere. This longitude from the 0 degree towards the left, it is the western hemisphere, and at the right, this is the eastern hemisphere. All right, this is your eastern, this is your western hemisphere, and it also divides the Earth into eastern and western hemisphere. So it is the longitude which divides Earth into two equal eastern and western hemispheres, and it is the equator which divides into equal northern and southern hemisphere. So this is a bit about longitudes. As I have told you that it decides the time. How is it that we will discuss in our next lecture. So as far as longitude is concerned, look over this slide, and here you can see very clearly it is given Greenwich meridian, that is at 0 degree, that is equator. Then is your 20 degree east, 40 degree east, 60 degree east, all to the right of the Greenwich, that is prime meridian. All the angular distances, these are given in degrees, and that is at the right hand side it will be degrees in east, at the left hand side it would be degrees in west. So this is how the meridians or the longitudes are basically important and are given. So longitudes are angular distance. I have explained you how they form the angle, measured in degrees along with equator east or west of the prime meridian. So this is the prime meridian, and this is east or west. Simple. It was decided in 1884. Why was it? Because I have told you it passes through an observatory where maximum number of scientists were working on these things, and at that time London was dominating over whole of the world, and so it decided and it took a decision which is, and because of which the time has also been decided. I'll explain you all these things, how the time and date changes. We will discuss all these things in our next lecture. So the prime meridian is 0 degree, from which all of the meridians radiate eastward and westward up to 180 degree. Eastward, from here it will start, it will go till 180 degree. From westward it will start and go till 180 degree. So 180 degree east will exist, 180 degree west will exist, but 190 degree east will not exist, 190 degree west will not exist, because then it is the direction east and west is kept till the limit of 180 degrees because of half circulation. Unlike parallels of latitudes, all meridians are of equal length. This is very important. You can see that all meridians are of equal length. The reason is that it is connecting between north and south pole, which is at equal distance. So the equator, we have read that equator is the longest latitude, but when it comes to longitude, so longitude all are of equal length because they just join north and southern pole. Now, why is it important that I have told you that longitude and latitude both are important for deciding any place on Earth? For example, this Hyderabad, which is in Pakistan, and Allahabad are situated on the same latitude. Latitude means these. Okay. So if this is India and this is Pakistan, focus on this part. So there must be Allahabad, and here it must be this Hyderabad in Pakistan. Both are lying on the same latitude. So won't it be very difficult that if you give only latitudinal degrees and you want to do a bombing on Hyderabad in Pakistan, and just because you are having the latitudes, no longitude, so you bomb it in Allahabad in India. So that is why this confusion would be, it can be removed only when we have longitudes also, as I have explained you, XY plane and all these things. So in order to locate them precisely, we must find out how far east or west these places are from a given line of reference running from the north to the south pole. So 0 degree prime meridian is the point of reference, and the distance is taken accordingly. Obviously, the degrees can be also changed into minutes, and how all these things are done, how we take the time at different places, how we decide the time zones and everything, that we'll be discussing in our next lecture. So thank you very much for listening to this lecture, which was on latitude, longitude, and rotation of Earth. In our next lecture, we'll be looking off that how time and date of a place is decided and how it changes when we move from one place to another, and how it is kept universal throughout the globe without affecting the time zone as in reference with other countries, but still it's very difficult to manage. So to avoid those difficulty, we have a set standard, and we'll be looking after all these things. And in our next lecture, we'll be looking after these aspects also. So thank you very much, and please subscribe us on BN by IAS, and you can also log in on bnbyias.com, and you can see several other important materials for GS and law optional as well. You can also contact us on this number for any further inquiry. So thank you for the lecture, and have a nice day.
For more videos, subscribe to BN by IAS and press the bell icon to never miss an update.